Okay, students, my voice is audible for you?
Audible, ma'am.
Okay, Nana. Okay, ma. I will show my syllabus PPT presentation. Okay. Today we will discuss our total syllabus and which topics included in our syllabus. What are the importance of syllabus? Now discuss in this class. Okay, students, my PPT presentation visible for you?
Yes, ma'am. Yes, ma'am.
Okay, Nana. Okay, Nana, this is K. Prasanna, Assistant Professor in Department of Chemistry, Basic Sciences and Humanities. Okay, today we discuss what is our syllabus and what topics included in our syllabus. The total information we will discuss in this session. Okay, so our subject name is Applied Chemistry. So that applied chemistry mainly consists of 5 units. So first one is polymer technology, and second one is electrochemical cells and corrosion, and third one is material chemistry, and fourth one is spectroscopic techniques and non-conventional energy sources, and fifth one is advanced concepts are topics in chemistry. This is totally our applied chemistry syllabus. Is nothing but this subject or this course consists of 5 units, Nana. Okay, so polymer technology, this is complete unit. Electrochemical cells, corrosion and simple unit. Material chemistry again consists of 2 parts, and fourth unit also consists of 2 parts, and fifth unit as usual common unit. Okay, so this third unit again consists of 2 parts, part 1 and part 2. Okay, in part 1 consists of topics are non-elemental semiconducting materials, insulators and magnetic materials. And part 2 consists of main topics are nanomaterials, liquid crystals and superconductors. Okay, this is our third unit. Next one is fourth unit, is nothing but spectroscopic techniques and non-conventional energy sources. This unit also consists of 2 parts. First part is spectroscopic techniques. Spectroscopic techniques is nothing but in this part may include what is spectrum, what is electromagnetic spectrum, how to what is the instruments of UV, IRs and NMR spectroscopy and CT scan. The total instrument techniques explained in this part. Next, second part is non-conventional energy sources. Okay, in this non-conventional energy sources may include renewable energy sources like solar energy, hydropower energy, tidal energy, wave energy, ocean energy. This type of all energies included in this part 2 of fourth unit. Next, fifth unit is advanced concepts or topics in chemistry. Again consists of 2 parts, computational chemistry and molecular switches. This is totally our syllabus. Ma'am, my voice is clear for you, Nana?
Clear, ma'am.
Okay, ma'am. Okay, Nana. Next, so we go to first unit, polymer technology. So in this unit, mainly consist parts are polymerization, plastics, elastomers and composite materials. Okay. Now we will explain, or I will explain polymerization topic. So in this polymer technology, first topic is what is monomer, what is polymer, how to form polymerization by the combination of monomers, how many types of polymers are available, what is the classification of polymers based on monomers, and finally discuss properties of polymers like physical properties and mechanical properties. That all contains discussed in polymerization topic in our further classes detail. Okay, first, polymerization is nothing but number of monomer units reacted with each other and it forms a higher molecular weight product, that is nothing but polymer. That monomer to polymer formation is nothing but called as polymerization. In this polymerization topic, we discuss what is monomer, what is polymer, how to form polymer from the monomers, uh, how many types of polymers are classified based on monomer units, and methods of polymerization techniques like emulsion and suspension. What are the examples of emulsion polymerization and what are the examples of suspension polymerization? That all information further classes we will discuss completely in next classes. Okay, this is polymerization. Next, compounding of plastic. Plastics is nothing but, this is one of the Greek word derived, okay, from the word plastikos. Plastikos means which being molded into desired shapes, that is considered as plastics. Okay, here compounding of plastics also topic we discussed in plastics. Compounding of plastics is nothing but, plastics have some features and some characteristics, but we have added some ingredients, extra ingredients to the plastic material. Why? Because to improve the desired qualities of the plastic material. So that process called as compounding of plastics. Mainly, many types of ingredients we use like plasticizers, stabilizers, binders, colorants, antioxidants, plasticizers, stabilizers. These all type of ingredients added to the plastic material. That adding process is nothing but called as compounding of plastics. And again, we go to fabrication method. Fabrication is nothing but plain plastic by the method of fabrication. Fabrication completed by 4 steps. First one, compression. Second one, injection. Third one, blown fill. And fourth one is extrusion. Okay. Next, here I give some examples of plastic materials like safety helmets, wiring and cables, packing. Okay, these all are the examples of plastic materials we use in our regular life. And plugs, cabinets for TV, jewelry and handles. Okay, these all are the examples of plastic materials. And also another examples like compact discs, DVDs, lenses like sunglasses, eyeglasses. These all are the examples of plastic materials may regularly we use in our daily life. And plastic materials may also use in electronic gadgets like refrigerator trays and microwave grills and telephone sheets and toasters, kettles. Okay, and also and use in these type of all electronic gadgets. So plastics may use in various fields like electronic gadgets, domestic household materials, packaging industry, automobiles, telecommunications. In various fields, plastics may regularly be used. So these are the applications of plastics. Next, last topic in plastics is nothing but recycling of e-plastic waste. Don't worry, Nana. This is the only our introduction class, only for cover the syllabus topics only. Don't worry. In our further classes, we clearly explain based on every topic. Okay. recycling of e-plastic waste is nothing but waste to wealth. So here, after using of plastic materials, the plastic materials may use recycling process like landfilling, and also by using some chemical products may produce some energy and produce some plastic products and also produce some energy also. So these all are the uses of uh, recycling process. Okay, this is total information about plastics. And elastomers is nothing but rubbers. So here, observe this diagram. This latex is nothing but simply considered as one of the natural rubber. This natural rubber mainly collected from the tree known as Hevea brasiliensis. That latex may use in various laboratories. We prepare some synthetic rubbers like these rubber bands, gaskets. So these all are the best examples of rubbers. In elastomers topic, we may discuss introduction. So what is natural rubber? What is synthetic rubber? What is the difference characteristics between synthetic rubbers and natural rubbers? How to prepare some synthetic rubbers like guanines, thiopar and polyurethanes, and the type of synthetic rubbers may consist which type of properties and where it is used. So those all type of information we will discuss in further classes in elastomers. Next, examples of rubbers like gaskets, like gel pads, uh, cashews, and chewing gums. Okay, these are also examples of rubbers. Next, composite materials. Okay, composite materials is nothing but these are very stronger than the plastics and rubbers. Plastics and rubbers. Okay, so here observe the some examples of composite materials like in automobile industry and circuit boards. These are the examples of composite materials. Composite is nothing but mixture of components like plastics and rubbers. Okay. Here some examples we may given like fiber reinforced plastics, conducting polymers, biodegradable polymers, biopolymers and biomedical polymers. These all are the examples of composite materials. Composite materials like artificial teeth and to prepare contact lenses. These all are the examples of composite materials. Okay, ma? Am I right? My voice is clear for you? Students? Please respond here. Students?
Yes, ma'am.
Okay, ma? Okay, Nana, please respond here if any need. Okay. Next, second unit is electrochemical cells and corrosion. So, electrochemical cells is nothing but here mainly we observe the electrochemical cell is nothing but like galvanic cell or voltaic cell or Daniel cell. This is the best example of electrochemical cell. So in this unit, mainly we discuss what is electrode potential, how to produce electrode potential by using some chemical equations. So how to calculate the electrode potentials by using some electrodes, and how to write the electrode potential equation by using Nernst equation, and what is batteries or cells. So the total information we discussed in electrochemical cells. Here observe this diagram. This is the example of galvanic cell. So this is the representation of galvanic cell. So how to write reactant, how to write products, how to difference write the reactants and products. So this is the simply representation of a galvanic cell. This formula is nothing but useful for to calculate the electrode potentials. Okay, electrode potential is nothing but the electrode mass that is considered as electrode potential of the cell. Okay, so what is electrode potential? What is standard electrode potentials? What are the terms like R, T, F? These information in further classes we will clearly explain. Okay, next. Here, observe these diagrams. These are the electrode types. This is the standard hydrogen electrode. This is the calomel electrode. Generally, we determine the unknown concentrated solutions or unknown concentrated electrode potential by using these electrodes like standard hydrogen electrodes and calomel electrodes. So in further classes, we will clearly explain what is standard electrode, how to construct the standard hydrogen electrode, limitations applicable for standard hydrogen electrode as well as calomel electrode, how to construct, what are the solutions taken, what is the importance of this calomel electrode, the total information we will discuss. These are the simply types of electrodes. These electrodes useful for to calculate the electrode potentials of unknown solutions. Next, another topic in electrochemical cells, batteries or cells. Okay, batteries or cells is nothing but that simple electrochemical cell may arranged in regular linear manner. The total cells are connected to the voltmeter. That series is nothing but called as cells or batteries. Okay, here that cells again are of two types, primary cells, secondary cells. What is the difference between primary cell and secondary cell? Is nothing but a cell that can be used only once, those are called as primary cells. A cell maybe that can be recharged, those are considered as secondary cells. So in further classes, we will explain some examples of primary cells and secondary cells also. Fuel cells. So in our unit, we have fuel cells types like hydrogen oxygen fuel cell, methyl alcohol oxygen fuel cell, phosphoric acid fuel cell, and molten carbonate fuel cell. The total fuel cells we will again how to hydrogen recycling. Okay, what are the reactions taken in fuel cells? So, what are the importance of fuel cells? The total information given in fuel cell topic. Okay, this is total information about electrochemical cells in second unit. Okay, next, corrosion is simply this is part considered as another part of second unit. So, corrosion here mainly we discuss what is corrosion, how to attack corrosion. So which theories may explain the corrosion and how many theories explain? What are the next types of corrosions? So how to control the or how to prevent the corrosion? So and factors. So the total information discussed in this corrosion session. So please all of you observe this diagram. This is the simple difference between corrosion and pure metal. So simply consider as this is the pure metal, this is the impure metal. Which pure metal attack with the impurities of nature from the environment, that is completely attacked and it forms a reddish brown color layer. That is considered as corrosion. Simply define corrosion as the metal may be decaying or destruction of metal. That is considered as corrosion. So that is the simple definition. So mainly and dry theory. The two theories may completely explain corrosions may also available. So mainly here three types of corrosions there. One is galvanic corrosion, another one is differential aeration corrosion, and third one is stress corrosion. Okay, next. Factors influence the rate of corrosion. Which type of factors may influence the corrosion? Maybe temperature, rainfall, pH, reaction in acidic medium, anodic impure metal, and electrode potential of the metal, electrochemical series of the metal, that all factors may influence the rate of corrosion. Next, so these are the controlling methods or preventing methods, okay, or protect the metal from the corrosion by using proper designing and avoid the stress and add the cathode is nothing but cathode protection method. And another methods are electroplating, electroplating, galvanizing, tinning. These are all methods useful for prevent the corrosion. Okay. Next, another some methods also available to control the corrosion, like paints. Okay. So here many types of controlling or preventing methods we may discuss. So like surface preparation, cathodic coatings like anodic and cathodic coating, electroplating, electroless plating, and paints. These all are the controlling or preventing methods. Okay, the total information discussed in further classes. Next, third unit. Okay, ma? Students, may I clear for you? Please respond here, anyone? Students, please respond here. Am I audible for you?
Yes, ma'am.
Please speak loudly. Am I audible to you?
Yes, ma'am.
Okay, Nana. If any problem with my presentation or my voice, please inform to me immediately. Okay?
Okay.
Okay, ma?
Okay, ma'am.
May I continue? May I continue?
Yes, ma'am.
Okay, Nana. Please respond here, Nana, if any need. Okay. Next, third unit is nothing but material chemistry. So this material chemistry mainly consists of part non-elemental semiconducting materials. So in this unit, we first discuss what is metal, what is semiconductor, and what is insulator. What is the difference between metal and semiconductor and insulator? In this part, metal, semiconductor, insulator may define based on band gap between the electron transitions or orbitals. Okay, the energy or the band gap between the orbitals very low, that is considered as metal. The band gap between the orbitals, maybe it is considered as medium, that is considered as semiconductor. The band gap between the orbitals may very high, that is considered as insulator. So this is the how to define metal, semiconductor, insulator based on band gap. Next, these two methods are useful for prepare semiconductors. These two methods are same. This is the zone refining method. Next one is crystal pulling technique. These two methods are very important for the preparation of semiconductors. Here many types are available. Another one is distillation, epitaxy, diffusion, ion implantation. But many important preparation of semiconductors topics are, this is the zone refining process. These two diagrams are helpful for zone refining method. This diagram useful for Zoroarsky crystal pulling technique. In further classes, we discuss how to prepare semiconductors by using these two methods. Next, semiconductor devices. This is the PN junction diode. What is P layer? What is N layer? What is the difference between P layer and N layer? What is the situation before the formation of depletion region, and what is the situation after the formation of depletion region? The total information we will discuss in further classes, and how to act PN junction diode like transistors. So what is transistor? How many parts consists of transistor? How to carry the energy from one emitter to base or base to collector. Okay, so the total information discussed in transistor. Next, insulators and magnetic materials. So these two are the examples of best insulators. Okay. So insulators is nothing but which do not allow any electric current to pass through them. That type of materials considered as insulators. These two are the best examples of electrical insulators. Next, this is the magnetism. So these three examples are helpful for explain the magnetism. This example for diamagnetism, this example for paramagnetism, this example for ferromagnetism. So mainly based on magnetic properties, magnetism classified into three types: diamagnetism, paramagnetism, ferromagnetism. When a substance placed in magnetic field, it maybe repulsion takes place towards the substance, that is considered as dia. Towards attraction maybe takes place, that is considered as ferro. Complete attraction maybe takes place towards the substance, that is considered as ferro. So these three diagrams explain diamagnetism, paramagnetism and ferromagnetism. Next, part 2. So part 2 is nothing but nanomaterials, liquid crystals, superconductors. These three are the main topics. So first one is nanomaterials. So here, this is the introduction topic. Here given some examples of nanomaterials like a pinhead, a human hair, and hydrogen bond, and a strand of DNA, and red blood cell, A4 sheet of paper. These all are the best examples of nanomaterials. So nanomaterials is nothing but these are the size from 1 to 100 nanometer diameter. Those all are considered materials are nanomaterials. So next, this is the salt gel method. This salt gel method useful for to prepare nanomaterials. Okay, this method clearly explained in further classes by using some steps. Okay, this is the introduction and examples of nanomaterials. This is the how to prepare nanomaterials by using salt gel method. So this is introduction, this is preparation. Next, here mainly three theories available. So Brunner Emmett Teller theory, BET, and SIM, scanning electron microscopy, and transmission electron microscopy. These three theories mainly useful for to explain the complete characterization of electrons in nanomaterials. Okay, this is the useful for TEM explanation. This diagram useful for explanation of SEM. Okay, next, nanomaterials examples like graphene sheet, fullerenes, carbon nanotubes. Like observe, these are the plain sheet type of materials called as graphene sheets. Round ball shaped structures like considered as fullerenes, like tubular form structures considered as carbon nanotubes. These all are the examples of nanomaterials. Next, liquid crystals. So what is liquid crystal? Is nothing but simply defined as liquid crystal is nothing but the intermediate state between the liquid state and crystalline state, that is considered as liquid crystal. Here may observe the some types. Those are leotropic liquid crystals and thermotropic liquid crystals. So what is leotropic liquid crystals? What are the characteristics of liquid crystals? And what is thermotropic liquid crystals? How to may classify the thermotropic liquid crystals? Again, so the total information we will discuss in further classes. Next, these are the applications of liquid crystals. Applications is nothing but uses. Okay, so mainly liquid crystals used in digital display and thermographic applications. Okay, these are the uses. Next, superconductors. So superconductor is nothing but the material which offer no resistance at absolute zero. Those are called as superconductors. These are of two types: type 1 superconductors, type 2 superconductor. What are the characteristics of type 1 superconductors? What are the characteristics of type 2 superconductors? We will discuss in further classes. Next, where it is used superconductors. Mainly superconductors used in MRI scan and also navigated trains. So main purpose of superconductor used in navigated trains and also using MRI scans. Next, fourth unit. Okay, ma, may I audible? Okay, Nana, may I audible?
Yes, ma'am.
Okay, ma. Next, Nana, fourth unit, spectroscopic technique. In this unit, mainly we discuss what is spectrum. So, what are the some definitions may available? What is magnetic field? What is electric field? What is propagation direction? What is wavelength? So that all definitions may introduce in this spectrum. Next, this is the instrumentation of IR. Next, this is the instrumentation of FR or FTIR instrumentation. Next, so those are the instrumentations. Next, in fourth unit, part 2 is nothing but non-conventional energy sources. So this is the example of PV cell. So by using solar energy, how to convert electrical energy? By using PV cell or polar cell. So that is considered as our photovoltaic cell. So that is also one of the example of non-conventional energy source. Next, this is the example for hydropower plant. So by using reservoir water, how to convert electrical energy? By using hydropower plant. So this information clearly explained by some videos through some videos. Next, geothermal energy. So how to extract heat from the underground part of the crust? That heat, how to convert the electrical energy by using geothermal power plant? That also we will discuss in further classes. Next, tidal power plant. So from the ocean, we observe the tides. Some tides are high tides, some tides are low tides. By using that high tide, low tides, how to convert the energy from tidal energy to electrical energy. That is explained by tidal power plant. Next, wave power plant. In the oceans, uh, in the ocean, maybe due to some temperature differences, wave produces. That wave, how to convert electrical energy? By using wave power plant, that is also explained in next classes. Next, OTEC power plant, ocean thermal energy power plant, that is also explained in next classes. These all are the non-conventional energy sources. Okay, non-conventional energy sources are renewable energy sources. So these non-conventional energy sources are totally explained by clear some videos. So what is wave power plant, how to construct wave power plant, how to produce waves, how to convert that wave into the electrical energy by using generators and rotators. The total information we will discuss in that topic of non-conventional energy sources. Next, last unit is advanced concepts or topics in chemistry. So this is completely different from intermediate syllabus and also first, second, third, fourth units. So computational chemistry. So in this unit mainly we discuss how to how to solve the problem by using computer. That is considered as computational chemistry. Okay, am I clear? In this unit mainly we discuss how to solve the chemical problem by using computer. That is considered as computational chemistry. In this computational chemistry, mainly we explain how to molecular modeling and docking, how to model the molecule and how to docking the model. Next part, molecular switches. Okay, so observe this. By using computer, how to solve the chemical problem. That is computational chemistry. Next, this is the molecular modeling, how to shape the molecule. This is molecular docking, how to connect with other ligands or how another intermediate compounds. This is the docking. Next, molecular switches. In this unit, molecular switches, molecular motors, molecular machines, rotaxanes, catenanes, molecular shuttles, molecular elevator may clearly explain in next classes. Okay, so this is also molecular switch. Okay, ma. This is our total 5 minute syllabus. Okay. Okay, ma, students? May I clear to you?
Okay, ma'am. Yes, ma'am.
Okay, ma? Wait few minutes. In next class, we will discuss. Okay, in next class we will discuss on Unit 1 Polymer Technology clearly. Okay, so wait a few more minutes. I will stop my presenting. Please, students, all of you wait one more minute.